Hello all, welcome, and today we're going to continue our discussion about matter. So, as I was saying, matter, it's everything, can be subdivided into two categories. And we had already previously talked about the fact that there's this stuff called pure matter, and pure matter can be classified into elements or compounds, right? And we said that an element is where there's only one type of atom, whereas a compound, you have to have two or more different types of atoms, specifically bonded together. But there's also the other set of matter, impure matter. And impure matter is really just mixtures, physical mixtures, not bonded together pure matter. And all mixtures are a mixture of some combination of these two, the elements and the compounds, mixture of pure matter. But we can actually subclassify those mixtures into two categories. We have homogeneous or homogeneous mixtures, and we have heterogeneous mixtures. Now, homogeneous mixtures are, by definition, evenly mixed throughout. And really, what that means is that they're mixed all the way down on the molecular level. So if we were to look at it on the molecular level, if we had that ability, we would see that everything is evenly mixed throughout, right? And some great examples. Oh, sorry. The naked eye can't see the difference between the different pure substances in a homogeneous mixture. And if we look at our example, salt water is a classic example where we know that there's salt and there's water within the ocean, but you can't see where the salt is, you can't really see where the water is. Another great example of a homogeneous mixture is actually brass. Brass is a mixture of copper and zinc in the metal, but it's not like you can look at the metal, and we do have to be careful because these little buttons up here are not made out of brass, but this bar right here is made out of brass. And you can't really see where the copper is, you can't really see where the zinc is. So any mixture that is evenly mixed, thoroughly mixed, down to the molecular level, we call homogeneous. Now, our other types of mixtures we call heterogeneous mixtures, and those are simply pure substances that are unevenly mixed. Okay? And those pure substances that are unevenly mixed, we can see the different substances, those different substances on the molecular level, meaning with the naked eye. You can literally see them, and that's the big difference between a homogeneous and heterogeneous mixture. Let's take a look at some examples of heterogeneous mixtures. My favorite example is pizza, because when I look at the pizza, I can see, in that pizza, I can see where the crust is, and the sauce, and the cheese, and the pepperoni, and the onions, the peppers, and I think there's some scallions there. You can see the difference there. Unlike with the salt water, where you can't see where the salt in the water is, here you can see all the differences. And the other classic example is oil and water. And we can see that there are the little globules of oil, and we can see that it's all in water, but you can tell, like this part, this glob right here, clearly it's oil, and this part in between is clearly water, right? So, what type of problems would you expect to see? Well, we call them particle diagrams. Reminder about particle diagrams. Given the key, where each different shape represents a different type of atom, elements would look like this. Now, please note that over here you can see that we have just a bunch of triangles. That's pretty obvious. Down here in the elements, we have to be careful. The reason that this sample down here is considered elements is because while these two circles are bonded together, they're the same element. They're a blue circle. And for a compound, for something to be a compound, it has to have two different elements. So yes, these would be considered molecules, but they're still elements. Now, compounds. All of these, if you look at these three samples, 1, 2, and 3, you can see that each particle or each molecule within the sample is composed of different types of atoms, at least two. We have a triangle and two circles, two triangle circle, right? Triangle circle. That's why these are all compounds. Now, we know that this sample down here, this one here, this one here, and this one here, those are considered molecules because they do have more than one atom bonded together, but only these are compounds. This right here, this is in molecules, it's just an element. Okay, so moving on, let's look at an example problem. Which of these two samples I'm going to show you would be classified as a mixture of elements? And our key here, same thing as before, Circles are atom A, triangles are atom B. Here is our sample A, and here is our sample B. So take a minute, figure out which one of these two would be considered a mixture of elements. Hopefully, you figured out that when you look at sample B, every single particle in here is the same type of atom. So these two right here, that's a mixture of the same atom. And this triangle right here, that's a mixture. I'm sorry, that's not even a mixture. That's just a single triangle. So if we look at here, sample B, that is a mixture of just elements. Element, whatever this would be, two circles, and this element right here. So sample B would be classified as the mixture of elements. So then that leads to the question, how would we classify sample A? Well, if I were to look through sample A and look at each individual molecule, I notice that these molecules are the same, so therefore that must be an element. This molecule right here, that must be a compound because I see a triangle bonded to the two circles. So therefore, if I'm seeing element and compound, we'd simply classify A as a mixture of an element and a compound. Thank you so much. I can't wait to see everyone in class. Have a wonderful day.